All right, let's do some homework problems and some problems that are very similar to homework problems. We're going to start with letter 18. Number 18. Yes. The number 18 is not that. I pulled up the wrong thing. Number 18 says, find the domain using interval notation. 18 is this function. 1 divided by x squared minus x minus 6. X squared minus x minus 6. And we want the domain. So remember, the domain for these functions is everything except when the denominator is equal to 0, or when we have the square root, or fourth root, or sixth root of a negative number. So that we need to figure out, okay, when is the denominator equal to 0? Because when the denominator equals 0, right, that's going to be undefined here. When this is true, it's going to be undefined. So we have to solve this equation. It's a quadratic equation. There's a couple of ways we can solve quadratic equations. Quadratic formula works. Factoring might work. We have to try to factor it. See if you can remember your algebra. If you're a little rusty on solving quadratic equations, reach out to me. I can give you some resources. Okay. So we have this right here. Let's try to factor it. It's a trinomial. Leading coefficient is 1. There's no number next to the x squared. It says if we can factor it, it'll look like this. This tells us the first sign is a negative. And this tells us the second sign has to be opposite the first sign. So we need something that multiplies to 6, whose difference is this coefficient of 1, negative 1 specifically. We're going to say minus 3 plus 2. And check our answer. X squared minus 3x plus 2x. That's a minus 1x. Minus 6. Checks out. And then right here, this is true when x minus 3 equals 0, or when x plus 2 equals 0. Because if you have two things multiplied by each other, and one of them is 0, then the whole thing is equal to 0. So it's going to be true when x is equal to positive 3 or negative 2. So this right here, right? This right here is when the function is undefined. These are the problems. We don't want problems. We want everything except the problems. So our domain is going to be every number except negative 2 and positive 3. On the number line, right, it's everything to the left of negative 2, everything to the right up until 3, and everything bigger than 3. We don't want negative 2. We don't want positive 3. Our domain is going to be negative infinity to negative 2, union negative 2 to positive 3, union positive 3 to positive infinity, or you can write this in set builder notation. It's a set of all x such that x is not equal to negative 2 or positive 3. That's our answer. Let's do another one. All right, so if we do the next problem, we're going to look at problem number 22, which is also a domain and range problem. If we look at problem number 22, we have the square root. Oh, this is a nasty one, which is why we're doing it here. The square root of x minus 4 divided by the square root of x minus 6. We also need the domain. Square root of x minus 4 divided by the square root of x minus 6. So again, right, there's two things happening here. Now we have square roots and fractions. We have to take care of everything, right? Need the inside of a square root. We need the inside of the square root to be positive or 0. And, right, we also need the denominator to not be 0. We need both of these conditions. If either one of these fails, we have a problem. If the inside is negative, that's not real. If we're dividing by 0, that's not real. So we have to look at a lot of things here. So what's inside the square root? Well, there's two square roots. We need the first thing inside the square root to be at least 0, and, right, we also need the others inside to be greater than or equal to 0. And we also need the denominator. There's a lot of things in this question, right? Which is why I'm doing it. It's later on in here. We need the entire denominator. This is everything in the denominator. We need this to not be equal to 0. This is our domain right here. Our domain is all the x's that satisfy these three things. So we're going to have to solve a little bit. So if we solve each of these, add 4 to both sides, that's going to be that x is bigger than or equal to 4. And solve this one. X is bigger than or equal to 6. And solve this other one. We have to get rid of a square root. What we're going to do is square both sides. We're going to get x minus 6 can't equal 0 squared. Add 6 to both sides. And we're going to get that x cannot equal 6. So these are the 3 requirements. Let's put all of these on a number line. Let's color code it too. Let's have this one be red, this one be blue, and this one be yellow. So we need x to be bigger than or equal to 4. Close circle, bracket, they both work. We also need the blue. We need x to be bigger than or equal to 6 as well. And we also need yellow. Everything except 6. We need all 3 of these. So the question is, where do they overlap? That's our answer. Our answer is, where do they overlap? What parts of the number line have all 3 of these? And the answer is right here. They overlap when x is strictly bigger than 6. Right? Because notice the yellow bubble's not filled in. They overlap right here. In interval notation, that's going to be, has to be bigger than 6, like so. Or you could use set builder notation. This is the set of all x such that x is strictly bigger than 6. And that's your answer right here. That's how to approach these more complicated domain problems. Okay. And it's a good idea, especially with one this complicated, to do some checks, like plug in some numbers in this interval. Like 7, for example. 7 should work. You plug in 7, you should get a real number. And something outside this interval, like 5 or 6, you plug in 5 or 6 up here, you should get something that's not a real number. Okay. That's one way to kind of check your answer, that this is the domain. This is the set of everything that works. The set of everything that's going to give us a real number as our output. Let's do 36 next. So 36 is this one. Find the domain and the range of this graph. Okay. So it's going to be maybe a little hard for us to do this. So for the domain, that's going to be all the x values. You can kind of drag. I wonder if it's worth copying this down on my own. I wonder if this will work. Copy. Can I paste an image? Well, I'll figure that out, not on the video. The idea, right, is that domain's all the x values. What's the furthest to the left we can go? The furthest to the left we can go is right here. I don't know where that is. It's not 2. 2 is right here. It's a little to the left of -2. Let's estimate. Maybe it's 2.2 or something. I don't know. For the domain, right, the furthest to the left we can go is negative 2.2. Estimate, guess. And it's an open circle, so it's not included. Parentheses. How far to the right can we go on this function? We keep on going right, keep on going right, keep on going right, and there's an arrow. So we can go as far to the right as we want. That's infinity. And similarly, for the range, how far down can we go? How far does this function go down? The lowest point on this function is right here. What y value do we have here? This is a y value of negative 4. The smallest y value is negative 4, and it's included, right? We do hit this point. And then what's the highest this graph can go? Well, over here it only gets up to 10, but that doesn't matter. Because over here it gets up as high as it wants. So it goes off to infinity. And we can write the domain and range like this. Do problem number 40. Sketch a graph of the piecewise function and write the domain in interval notation. Okay, we're going to use Desmos for number 40. Sketch a graph, write the domain in interval notation. So it's x plus 1 for negative x and x minus 1 for positive x. Okay, so let's go over here. Make a new one. It's y equals x plus 1. Wait, I've already forgotten it. X plus 1 for negative x. So this is if x is negative. And it's x minus 1 if x is positive. So this is what the function looks like here. Okay? So let's copy this down on our own piece of paper. We go over to our own piece of paper. And let's get my graph paper back. So for positive x, it's that diagonal line, that orange one, starting like this. And then for the other one, it's the purple line, kind of starting like this. What about open circles or closed circles? Open circles or closed circles? Well, x is not included. X equals 0 is not included on either of these. Neither piece has an equal sign, so it's actually going to be an open circle on both. All right. So when we look at the domain, this is what the sketch is. The domain is all the x values. So we can go as far to the right as we want, as far to the left as we want, and we have points here, points here, points here, but notice there's no closed circle here. There's only an open circle on both. So we never hit 0. The domain is actually everything except 0 here. Okay? And you can write that in set builder notation as well. It's a set of all x such that x is anything except 0. You don't have to give both of these. The only reason I give both is so you can see it both ways. But as long as you give one answer, I'm okay with that. All right, let me know if you have any questions on these homework problems. Good luck.